Hello, Calc. When I made this a couple days ago, I uploaded the wrong video. You probably noticed. So your video for tomorrow, which is Tuesday the 3rd, is not going to be up very soon. So it's too late for you. So you are excused from it. Maybe give you time in the beginning of class to watch it. We'll see. What was supposed to be up, I did actually make the video, but then I uploaded the wrong video and deleted the right video. So, starting from scratch. Our review is on limits. What is your limit with limits? Alright, hopefully there are no limits to your limits. I just have a hodgepodge of review ideas that are floating through my head, so hopefully you'll find them helpful. And the first type of limit we learned was find the limit of an algebraic expression with a variable as x approaches 5, x squared would be an example. What is that limit? And you simply substitute 5 in for x, and you get 5 squared, which is 25. Now sometimes, adding a complication, sometimes when we take the limit and put the 0 in this case a 0 in here, it creates a mathematical impossibility. So then you have to think of finding the limit another way. This one is a graph that we should remember from pre-calc, and it is a volcano, and it stays positive, and it has an asymptote. So it looks like that. So you can see as x approaches 0 from the left and the right, remember how we check as x is way down here, the value for y, which is what the limit is fairly low. But as we go closer to 0, the x values create or match with a y value that's much higher. So it's these y values that we're looking at. So as we come in from the right, it's getting higher and higher. As we come in from the left, the same thing. So we say that that is an infinite limit if it's doing the same thing from the left and the right. What happens when the limit... Oh, and by the way, if you don't have the graph or the ability to graph it for some reason, we use a table. So you would be approaching 0, so maybe start at 1 and then 0.5, that's 1/2, and then maybe 0.2, 0.1, 0.01, and see what the values are happening as you come in closer to 0 from the right. And then do the same thing from the left. So you'd be at, say, -1, -0.5, -0.2, -0.1, -0.01 as you come in from the left, and these numbers will get infinitely high as you try those. Alright, so a table is an idea to use when you can't do anything with the algebra to improve the situation, or you don't want to rely on the graph. How about the limit as x approaches 0 of 1 over x? So this graph, you'll recall, is a slash slash, and as we come in from the left, the value for y is dropping, and as we come in from the right, it's growing. So it's approaching negative infinity from one side and positive from the other. So we say the limit does not exist. It has to be the same from the left as it is from the right. Another common limit we run into, say, as x approaches 4 of 3. And this expression has no variable in it. There's no x in this expression to substitute a 4 for, so we just get a 3. Sometimes it's a variable, say as x approaches 2 of b. But b is not an x. So it's just an expression without an x, so the limit is b. So these are just all the different kinds of limits that we've seen. What about this kind of notation? Go back to the slash slash. What is the limit as x approaches 0 from the right? I just wanted to remind you that that little plus sign meant from the right. And we already discussed that it's infinity, it's getting infinitely higher. And the limit as x approaches 0 from the left would be the little negative sign. And we already shown or discussed that that's negative infinity. So I remind you of that notation. Okay, so let's do some limits that are approaching infinity. So when we're looking at a limit as x approaches infinity, we have this trick up our sleeve. Say we have the expression 3x plus 5 over 7x plus 5. And the key when you're approaching infinity, when you have a rational expression like this, you divide through each term by the greatest power of the variable in the problem. So the greatest power of the variable in the problem is just x. So I'm going to divide everything by x, which is algebraically sound. It's like I'm multiplying by 1 over x divided by 1 over x, which is a 1. So now this reduces to 3 plus 5 over x, 7 plus 5 over x. And the limit as x goes to infinity, this expression as x gets infinitely large, this goes to 0, and this goes to 0, and these remain. So the limit of that is 3/7. So let's try another one of those. The limit as x approaches infinity of 8x squared minus 4x plus 1 over 16x squared plus 7x minus 2. This time I'll divide by x squared. This goes to 0. This goes to 8 over 16, 1/2. What about the kind that look like this? Say the limit as x approaches -4 of x squared plus 6x plus 8 over x plus 4. So if we put a -4 in here, the denominator is 0, another mathematical impossibility. So what we try when that happens, the first thing is to factor. When we factor the numerator here, it does work out nicely because these cancel, and now we can put the -4 in for the x and we get a -2. Alright, how about this one where we're not so lucky? Suppose x approaches 2 and we've got x plus 3 over x squared plus x minus 6. So at first